So I'm Laurent Picard. Let's get to know each other first to start with. I joined Google a few months ago, and I focus on Google Cloud Platform. I'm a software engineer, by the way. A long time ago in my previous life, I co-created Booking and was CTO of it. And earlier in 2000, I co-invented the first European e-book reader. So it was a big tablet like the iPad, 1 kilogram, back in 2000. So it was working too early. I'd like to know a bit who you are. So who are developers? Yeah. So who is a Java developer? Who is not? I'm joking. Who knows Python? Okay, good. So I'm sorry there's going to be some Python code, okay? Who's already developed on an IOT device, Raspberry maybe? Okay, so I hope you will learn something. And who is already working with cloud services? Okay, goodness. Okay, great. So quickly, we'll have an introduction about the Raspberry Pi for those who don't know it, about Google Cloud 2, but we will get in to have some action, and I hope that's the most interesting one. That's why I needed 2 minutes to set up my ears. So first of all, Raspberry Pi. So I chose this device because it's one of the most popular. It was made by the charity in the UK called Raspberry Pi. And so far as of today, they must have sold something like 15 million units. So that's very, very successful for such a small device. And in 2012, it was actually the first actual computer, but with the size of a credit card. Okay. The latest model, the Raspberry Pi 3, that you can see here, it costs around 35 euros. But it's a whole computer, you can do anything with it. There are many different other alternatives. You can find more powerful devices, even 100 or 200 euros. You can find cheaper ones, so it's up to you, you have plenty of choice. One of the most known after the Raspberry Pi is the Arduino platform. Above that, I wanted to have something to show you. I chose the rainbow hat. So it's a small hat that you put on top of the Raspberry Pi. Okay, let me show you. It's just this little thing. Okay. So you just plug it in, and then you have sensors, inputs and outputs. And what you have on this small board, you have segmented displays. Sorry. You have segmented displays here. Here. You have input capacitive buttons. You have LEDs on the top. And you have other sensors that will check that. It's made by Pioneer, so it's made up from Parrot, Monkey, Robot and Ninja. So it's also a UK company. But this one is not a charity, and they're making many accessories based on the Raspberry, the Arduino, and other IoT devices. Okay, so that was a quick introduction about IoT devices. Likewise for Google Cloud, so Google Cloud is made of dozens of products, so I won't detail them here, but what you can memorize is that they are grouped in computing, data, machine learning, storage databases, and of course many developing tools. So I just discovered that within the last year, and you can handle any product very quickly, and we will see a few of them in this session. But let's go and have some action, okay? So what I'm going to do is use the Raspberry Pi, the rainbow hat on top of it, and Google Cloud, and see how we can make all of it to work together. First, a disclaimer. So no servers are going to be harmed during this session. So I have to explain a little bit. So maybe when you will read about cloud, you will see the term serverless mentioned everywhere. So what it means is that right now there are no servers for my team, right? I have a project that is existing, but there are no servers. And what we're going to do is to provision, to ask Google to bring up to life some services, and the servers will be commissioned on demand. So the great thing about this is that it's fully managed. So you don't have to bother at all about how it works, whether the network is okay or not. You just have to you can focus on your development. And the second disclaimer is that a Raspberry Pi might be harmed during this session. That's the risk with embedded development. So quickly, I will show you how you can start from the Raspberry. You can start actually from scratch. Most of the time when you get the device, it's working right out of the box. But with a simple micro SD card, you can boot up from scratch because everything is on the SD card. And so it's very easy to do it. And if you want to do it, it takes less than 5 minutes. After this step, so you see the micro SD card here. After this step, in 12 minutes, you will get the full installation of your OS. So in this case, I chose the Raspbian OS. So Raspbian is the Debian distribution for Raspberry. So I said it takes about 12 minutes, and in this case, you have to start up with a monitor, a mouse, and a keyboard. I will explain that after a while. So here you see the screenshot where I showed the Raspbian OS.
So I won't detail them here, but what you can
so first of all, is that I said monitor, mouse, keyboard. So this is for you to be able to handle the Raspbian desktop. So you are working in desktop mode. But here I am going to show you everything in headless mode. So it means I adjust my laptop as a development computer and the Raspberry Pi as an IoT device. So I'm not going to use the desktop that is coming with the Raspbian distribution. You can work in hybrid mode, so it means you could use the desktop from the Raspbian on your laptop. And in this case, you will use a remote desktop service like VNC or RDP on Windows. So the only thing that you have to do with the Raspbian desktop, and you shall not forget about it, is activate SSH and serial. For some reasons, they are disabled by default. But if you're going to develop, it's most useful, it's mandatory even. So you enable them, and then you shut down, and you will never need to use the desktop again. So a takeaway for today, it's not obvious, but if you're going to do embedded development, you will need, for sure, you will need a serial cable. So let me show you what it is. And if you don't have it, with the Murphy's laws, you will get into trouble. So it's something like that, okay? So if you're going to work with the Raspberry, please invest into this. This is 10 euros, and it will save your life at some times. So it's just made of 3 wires. So you need the ground pin, you need reception and transmission. And this is how you plug everything, either on the Raspberry board itself or on the top of the rainbow hat, okay? So there's just some configuration that you're going to have to do on your laptop to connect to it. Okay, sorry. Another takeaway is As you can see here, you might plug the power pin that is coming from your laptop, and the Pi will work. It will actually boot. You'll be able to use the Linux to connect to it. You might even be able to get some connectivity, and everything will look like it's working. But eventually something will fail, most of the time the network or something. So this is something not obvious, but such a small device needs a stable power. So here in my demo, so as you can see here, I have plugged the Pi to my computer. So but I could plug it into the power supply down there. So yeah, so remember, if you work with the Pi or any other device and something gets weird, check your power supply first. Then eventually, with the serial cable, you will get a console that you're familiar with. So the other advantage of this small cable is that it's a universal low-level connectivity means. It will show you the system boot. You will have all the information as early as possible. Also, as long as the USB is connected, even if you reboot your device, you will keep the serial connectivity, so you will save some time. Okay. The only drawback of this is that it's serial and then it's a bit slower than SSH. So of course, if you didn't ask, but if you're familiar with Linux, you will customize your environment. So of course, change your password, change your hostname. It's pretty handy to be able to recognize your device on the network, or if you have a few of them, give them nice names. Okay, and you'll see do I have a connection? Okay. So maybe I'm going to show you how I've done. Okay. So here it's a Windows laptop, but it's the same everywhere else. So here you see I can. Sorry. Yeah, I'm cheating a little bit. I'm going to connect in SSH. Sorry. Okay. The serial cable is plugged to another one. Okay, but I wanted to show you that I customized. Okay. Do you see anything here? Is it too small? Is it okay? Yeah. And here, another thing that you'll have to do if you want to work with the Rainbow Hat is you will have to activate to enable additional buses. So that's what I mean by SPI and I2C. So those are low-level hardware buses, and they are needed for the gear to communicate with the Pi. And the way it's done is, so as you can see, there's a command raspi config. Is that right? Thanks. Oh, okay, it's nicer. And here is my host name. So this is Asimov. Let me introduce you, Asimov. And in the interfacing options, yeah, here you see you can activate VNC if you want remote desktop, but what you're going to do is SPI and I2C. So this is also mandatory. Okay, let's skip. Okay, so for Ethernet, I won't go into details, but of course, it's pretty handy to have Ethernet configuration. Here, so I have connected the Raspberry Pi directly to my laptop, and this is how I can have I have a private network. I didn't want to mess with Wi-Fi or whatever. if you're working at home or in your office, maybe you will be able to use Wi-Fi and not the Ethernet. Okay, so it's pretty standard. So SSH, as I said, I showed you, it's another universal means of getting connected to pretty much any computer. So it's a network protocol and it's secure. So here I am connected in SSH. Another thing, you might run into trouble just because there are some drivers or some packages that are not up to date. So when I started from scratch, I told you 5 minutes, 12 minutes. Here, you can update your whole system. Most of the time, it's never up to date. So it just takes 8 minutes, and it will save you some time later. So that's why I mean by it's coffee time maybe, just when you start, update your device, and you will save hours later. So for Wi-Fi, just to be exhaustive, this is the configuration that you can put up. Here, just before coming, I hope it will work. I set up the Wi-Fi of the Pi with the Hotel Napoca network. And another takeaway, and this is quite weird, eventually the Wi-Fi gets unstable. That's weird because it's a device that's been manufactured for years. So I think there's a trouble with the driver, the Wi-Fi driver. And actually it comes from the power management. So after some time, and maybe in some configuration with some Wi-Fi version, like 11N for instance, the network will just freeze. So there's one workaround, is just to disable the power management. So it means that the Wi-Fi will just get up to speed, stay up to speed all the time. And here you can see the command if you want to disable the power management, and that's the case here. Let me show you. Oops. Okay, you see power management off. And if you check the default packages on your Pi, you'll find out that you have pretty much all the languages. So Java, C, C++, Node.js, Python, and Ruby, and many others. For instance, Scratch, if you want to play with the Pi with your kids. And I'm going to show you Python code. So I checked the Python packages by default. And we have Flask and Jinja. So that's if you want to do some web development, if you want to have a web server on your Pi. NumPy, if you're a data scientist, for instance. And here, pretty great. I already have the Rainbow Hat and package, so it means I'm going to be able to pilot my Rainbow Hat without doing anything. And also the GPIO package. So GPIO is General Purpose Input-Output. So this is a low-level package, and it means that with this package you'll be able to control the different pins. So the pins here on the side are connected to pins on the CPU, right? But they can also be connected to some other peripherals. And with GPIO, with the GPIO package, you'll be able to control exactly what's on every pin. And this is how it works for the Rainbow Hat. You can say, okay, this pin is an input, this pin is an output, or you have also floating pin without any defined state. And so it means that you're going to control exactly which voltage you want on which pin. So this is also mandatory if you want your Rainbow Hat to work. For the development, so I'm working on Windows, as you could see. I wanted something very handy. I wanted to be able to develop on my laptop and get the code right away on the Pi. So what I chose, and I'm developing under VS Code. Many of you maybe are already, and there are more and more, I think. So what I did is I installed the SFTP add-on under VS Code, and with just this small configuration, so I'm specifying the IP address of my Pi. And here, of course, you have the password of my Pi. So don't tell it, it's very complicated. And here I specify the folder where I'm going to host my code, okay? And the rest is standard. The SFTP is on port 22. And there's just this option. Anytime I'm going to save a file under VS Code, the file is going to be downloaded right away on the Pi. So that's pretty handy if you want to change something and test it right away. Okay. So quickly, let's have a look at the different options of the Pi, and let's get it to work with some code, okay? So here, first of all, let's try to get the segmented display to work, okay? So in this Python code, you can see that I just have to import the display module from Rainbow Hat. The rest is standard, and I can use print, string, show, clear, and I can control any digit as I want. Okay, so let's try it. So first of all, I'm going to, maybe upload all the code. Yeah, it's already there. So let's show you. I'm going to remove everything. Yeah, just to show you how it works. Is that dangerous? Okay, it doesn't matter. And of course, I'm not going to save each file on a per unit basis. So what you can do is also call upload, and it will upload the whole folder to Raspberry. And here you can see I have all the code samples. Okay, so let's check the first example. Yeah, so I'm just with this code. Yeah, so I'm printing here any random digit alphanum with this one. Okay, I'm just waiting a little bit. And when I'm going to stop, I'm going to get the answer of the universe. Oh, it's a bit hard to, yes, but that's the answer. Okay, so next one. You can control the LEDs, so you can do something pretty nice with it. Let's check the code. So here you just have to import the rainbow module from the Rainbow Hat, and then you can set the brightness. You can change the state of all. There are actually 7 LEDs, so you can set the color for all of them, and you can also control each. So they call that a pixel, but you can control each LED individually. And here the thing I'm doing is, okay, I'm going to cycle within the color cube. So. Okay, so you see. So there's very little code involved. So next, there is a buzzer, so a piezo buzzer. So it's not very interesting and you won't hear anything, but if you want to play some music, so you can import buzzer and play a MIDI note or a note with the frequency, okay?
So if you're going to be able to give some orders or to command your device, the buttons are pretty handy. So that's pretty easy. You have some callbacks like press and release. And additionally, you have some small LEDs above each button. So let's try this sample. Sorry, that's number 4. Okay. So here, while I'm pushing the buttons, it's capacitive, so you don't feel anything. So you have press release for all of them. Okay, so pretty handy too. Then you have a sensor, so it's very small. I couldn't show it, so it's this one. It can measure the temperature and the pressure. And here, to do it, just import weather and call pressure and temperature. Okay, sample number 5. So here, as you can see, I'm getting the pressure and the temperature, but something is weird, right? 36 degrees. I'm not sure we have 36 degrees here. But the code is dead simple, right? So here I'm going to give you another takeaway, and maybe I do the only impression of the day, so forgive me. With sensors to scale, calibrate you will, okay? So that's something that Master Yuda could have said. And it's going to be pretty regular. When you're going to work with sensors, almost all times you will have to deal with calibration. There's almost no other choice. And here, the bad thing, it's a design mistake, is that they put this small sensor just right above the Pi board. So this sensor is getting the heat from the CPU. So, so this is pretty bad. So you will find some workarounds, but actually it's not going to work. So one way, for instance, I've tried, so I told you you're going to have to work with calibration. So here this is an example of how I could try to calibrate my temperature. So what I did is at the same time measuring, I can retrieve the temperature of the CPU with this command. And so I'm trying to compute something where I'm taking away a part of the CPU temperature from the temperature that I'm getting with this small sensor. So this is sample number 6. So here in this code, I'm taking 60% of the heat, of the difference of the heat between the two. So let's see what I get. Okay, 28. So it's still not very good, okay? So I can tell you right away this is not going to work. There's no way you can get a precise temperature with such a bad design, okay? But still, you can play with it. So now the question is, I can get some metrics from the Pi. How can I get them to the cloud? Because I can store them on the device, but if I'm measuring that over a few weeks, then eventually I'll get out of storage, and also if it gets broken or stolen or whatever, then I will lose all of my data. And also it would be nice to be able to analyze the data in real time. Okay, so for that I'm going to use the cloud. But first I'm going to prepare my code, because I don't want to do it too late. So, so here I have the get current metrics. I can show them on my console. But here is my loop, so it's pretty that simple too. So this is how I prepare. But okay, with the cloud, so we are talking almost about databases. So I've prepared my code to return rows. Okay. So here, for every sample, I'm going to return the timestamp. I want to know at which time I have got these metrics. I'm going to also remember the device, because eventually we'll work with many more devices. And I'm retrieving all other metrics. So the code is prepared. Okay, we can see how it works. So that's this loop. Okay. And at the same time, I have the temperature on top of the bar. Okay. Asimov is the name. Okay, I'm going to go a bit faster. So to upload the data, I chose BigQuery. So BigQuery is a big tool from Google Cloud, pretty versatile. It's a big data tool. Here, we're just going to stream the data to BigQuery, but you have to, if you have one thing to remember, is that BigQuery can handle petabytes of data. So you can upload or stream loads of data, and you can query them in a few seconds, even if it's petabytes. So quickly, in the Google Cloud Platform, you just have to set up a project, right? So this is an overview of the, I should have it here. So this is my console here with the Workstage project. Yeah, everything is project-based, so this is why I mentioned that. And here I have a project ID. So this project ID is going to be used in some parts of the code to identify where I want to connect my services. So here is the setup of the Cloud SDK on the Pi. It takes 2 minutes, and after that I have the basis of my environment setup, and I can already use gcloud commands on the Pi. So you can use it either on the web, on the Pi, on your laptop. There are many, many different ways. Then you just have to initialize your environment on the Pi or on your laptop. It takes 3 minutes, and then that's it. And then on the Pi, you just have to install the BigQuery client library. So it's going to be always the same case. You just install, so that's the Python command to install a package, pip install. And here I just query BigQuery, and it takes 2 minutes too. And one thing here is I will authenticate, so to retrieve the credentials from the cloud to the device. So they are saved here. And here is the code to create the BigQuery table. So the thing that's nice here is that you can define the schema quite easily. It's a bit like SQLite, let's say, except that it's able to handle petabytes. Okay, and the way it works is that you have a data set. Okay, so here the data set is Raspberry, and then you create as many tables as you want. So let's create a table. So here you have the schema of the table. Here I'm going to check whether the data set is there. If it's not, to create it, like that. And once I have my data set, then I just create the table if it's not there. Okay? So here I check the table, and if it's not there, I create a table. So let's get it to run. So that's the first time we're going to use Wi-Fi on the Pi, so hopefully it will work. Yeah. So the data set Raspberry was already existing. So here the table matrix has been created. So if I just refresh the data set, I should find my table. Yeah, the matrix table is right there with the right schema. Okay, timestamp, device, pressure, and everything with the different formats. Next step, we're going to stream the data. So let's check the code right here. Yeah, so the only thing compared to the previous code I had is that now I'm going to flush my rows to BigQuery whenever I want. So every second I'm getting the metrics on the pie, and here every 5 seconds at least I'm going to flush the data to BigQuery. So the only command here, of course, I get the client and the table there, and then the only command needed is create rows. Okay, and the rest of the code is the same. So that's why I call API stream. Okay. So it's starting. Yeah, and every second I'm getting a sample, like before, and every 5 seconds I'm going to upload the available metrics to BigQuery. So let's check it. So right away I can already do some SQL queries. Okay, so you see all the metrics that have been uploaded by Azure. Pretty simple, right? Okay, let's go on. Oh, actually that was the first one. So shall we stop, or do you want more? Yeah, a bit more? Okay. So next, so we're able to upload data, so to output something from the pie. So, but it would be handy to control the pie from outside. So you can imagine many different complex architectures, or you can develop your own solution. But there's one that I use where you need almost nothing. So it's the PubSub mechanism. Are you familiar with PubSub maybe? So PubSub is used by in many architectures. So there are publishers on one side and subscribers on the other side. And this allows you to decouple the code. So you can stream data or stream comments from one side and from one or many different publishers, and PubSub will just send them away to the subscribers. Okay, and this is here what I showed you. So from my computer, my laptop, I want to publish, so to send some commands to PubSub, and then the Pi will subscribe to PubSub and receive the command. Okay, so here again I'm going to use PubSub, so I just install the Python package. It takes 1 minute, and then I have 2 very simple pieces of code. First of all, as a publisher, I'm going to create a topic. So I create a publisher client. I get all the different settings. And if my topic is not there, I'm just going to create the topic. Okay, number 10. And here, let's have a look at PubSub. So PubSub has nothing. If I refresh my page, yeah, I have a topic. So the Pi has created a topic. It's called RPI commands. So, okay, I want to get commands on this topic. Now let's launch the next one. Sorry. So it's PubSub. So I'm going to subscribe to some command. So show you the code. So for the subscriber, you create a client. You have the same different settings, and then you create a subscription, and you subscribe to this topic, and you have a callback on message. And this is where I'm going to receive the commands from PubSub. You might receive one message a few times because this is distributed all over the world, so this is the way it works. So this is why I'm using a timestamp to ignore all other commands. Oh, I have an error. Okay, so yeah, so it means it's not going to work. It already exists. Yeah, okay. Let's do it again. I know I missed one exception. Okay, talking. So shall I pass or? Yeah, it means it's not going to receive. So I'm going to do something. I'm going to authenticate. I take 30 seconds. If it doesn't work, I will just pass that. I'm not sure that's the source existence machine tokens for quota administrator. Okay, so I'm hitting an error I haven't made before. So let's No, I don't know this case. For administrator, you can That's the risk with live demos. Okay, so it's not going to work. Okay, so let's move on. But the way it should work is here I would get a subscription and just I would send a command to the device. So next, if I have a device that's generating a lot of files or big files, so maybe I would like to store them in the cloud. So you can get an additional external drive, but you can also use the cloud. And in this case, you can use cloud storage and pretty much any cloud storage. So always the same, I'm installing the cloud storage client library. So it takes 30 seconds. And the code. So here, a storage unit is called a bucket. So you can consider it's a folder or drive. So it's a bucket, and here, if I don't have the bucket, I create the bucket, and then I can manipulate the files. So I'm going to create a blob with a remote file called like this. And what I'm going to do is upload from this code file, upload it to cloud storage, and then download it again. So I'm going to take this file, upload it to the cloud under this name, and then take it back, download it back again under this name as a copy. Okay. And let's have a look at cloud storage. So here I see my buckets. Okay, and in media, so the bucket has been created, and okay, so it's very fast, but the bucket has been created. The Python source code has been uploaded and downloaded back. So here, yeah, I have the source file here as a copy, but what I did is upload it and download it again. And here in the bucket, I can see my Python file. Okay, so this is just an example. And I specify the encoding or the file type as text plain, but if it was a picture, it would work it would, sorry, if it's a common file, it will be recognized right away. So, everything is pretty simple so far. Isn't it more complex in real life? Yes, that is. But I wanted to show you, how much time do I have? Yeah. I wanted to show you that you can take pretty much any standard gear and plug it to your Raspberry. So, as an example, I have a USB cam here, right? So this is a webcam, right? So I'm going to unplug it from my laptop. So this is here. And going to plug it to my Pi. Okay. Yeah, so it's the IPvo, it's an HD webcam, and it's a universal video gear. So this is why it's going to work right away. So here's the code to show you how it works. So this time I installed the Python OpenCV. So this is a library to handle everything related to video. So you get it in 20 seconds. And you remember when I was talking about calibration. So here we have a new sensor. It's a video sensor. We will have the calibration issue again. So why? Because you need to focus when you have a camera. You need to get the white balance and everything. So most of the webcams have an autofocus. They have an auto calibration process. So most of the time it's when you power them on, they will take 1 or 2 seconds to calibrate. They will make the focus themselves. And so here the workaround. So for it to work, I would set the focus myself manually, and that would be the best case. But here I don't have the time to set the focus. I don't know how it's going to work or whatever. So here the workaround is that I'm going to skip 140 frames to let the webcam autofocus. Okay. And then I will just get the frame and save it as a JPEG. Okay. So that's number 13. So here, so the LED is on. So it's keeping the first frames, taking a snapshot and saving the snapshot locally. Okay, it's not, so it's called capture. And you see, pretty simple. And now let's try to get everything to work all together. So I have a bug with pub/sub, so I won't be able to send pub/sub commands, but doesn't matter, maybe. So here I combined all the different routines that you've seen before, and we're going to try to get it to work. Okay, so it's something like 250 lines that you should recognize. Okay, so let's try if the pub/sub error doesn't get everything to fail. Yeah, so it's subscribed to the Asimov subscription. It's in the loop, it's getting the metrics, and so it's streaming the data to BigQuery. And do I remember? I must have plugged a button. Yeah, I've plugged button C to take a snapshot. So let's try. So, okay, so button C. So skipping the first frame, so take your time to smile. So it's autofocus. It's going to take the first frame soon. Okay, the snapshot is saved and it's going to get uploaded. Yeah. And it just keeps streaming. So let's check. So here, this is my bucket. Hey! So without much configuration, okay? Okay, another, quickly, maybe in 2 minutes, another solution. If I want, so I can develop everything on the Pi, but there are maybe some batches, some processes that I could I could offload from the Pi and that I could process in the cloud. And for that, you can use cloud functions. So you can actually put some functions in the cloud, and you can trigger them with PubSub, with cloud storage, or directly from your computer with an HTTP request. So here, what I'm going to do is I'm going to configure a trigger whenever a picture is going to come from the cloud storage is going to be processed with cloud functions, okay? And I will explain later, okay? Nice. So maybe for the next one, a bit lower. So here, function details. So this is my cloud function. I'm going to change the trigger. So it's already configured. It takes 1 or 2 minutes the first time. I'm going to say, okay, whenever there's a new file in my bucket, so the bucket here is the Cloj media bucket. Whenever there's a new file in this bucket, so that's the file that's going to be uploaded from the webcam, I'm going to get this code to run. So this is Node.js code, and I'm actually doing 3 things. But okay, let's set this. Okay, it takes something like 30 seconds to change. So as you, maybe you can guess what it's going to do. Okay, so everything is still running. Almost finished. Okay, so my code, oh sorry, it's too small, sorry. So here my code is configured. So let's take a new picture. So meets smile. So it's still on. So it's a bit too long, so manual focus would be better. So the snapshot is taken. So it's going to be uploaded. Okay, done. So here I have a new file, right? And the result is going to be stored in another bucket. Is that, oh yeah, that's already finished. Let's try. Hey, hello David. Hey, do you recognize yourself? So the code has actually been using machine learning. And here is the code. Okay, let's. So this is my cloud function. It's also pretty simple. So I'm calling the Vision API, and I'm asking for face detection. Okay, and I'm getting all the different rectangles. And then what I'm doing is using Sharp, so that's an image processing module that is in the cloud. It was installed when I configured my code. I'm extracting every small face, putting it to file, and then uploading it to another bucket. And that's how you get this pretty easily. Okay. So let's see, maybe the biggest ones, or small ones. Hey, recognizing. Okay. Okay, let's go on. And yeah, my time is almost done. So does it scale to several devices? Of course it does scale. So here I have another one. It's the same pi, so this one is called Herbert. And yeah, I don't have the time. I prefer to show you something else. But basically here, if I just have to launch the same Python code, it will take different features at the same time, and everything will work, will scale, even if I have hundreds of or thousands of devices. Okay, and does it scale to millions of devices? So yeah, of course, this is natively scalable. But if you have millions of devices, then you will not be here. You will do everything differently. You will optimize. You will maybe work with MQTT natively. You will optimize your protocol, the network protocol you're using, and you will be maybe using Android things. So at scale for millions of devices, it's different, and you're going to be willing to administrate your fleet of devices. And this is not something you can do by hand if you have even thousands of devices. So then you will need a framework to be able to update your devices, to control them, to control the different fleets. Okay, and you can use something like IoT core. So this would be the subject for another topic. Okay, so it's time to wrap up. So we've seen many things. One thing didn't work. I will check why. So Raspberry Pi, BigQuery, PubSub, cloud storage, cloud functions, and I mentioned IoT core. So you can check everything online. Everything is, as you could see, I hope, very simple. Thanks a lot. So you can follow me on Twitter. So my last name is Picard. I live in Paris. And this is one of my first talks. So your feedback is very much welcome. How can I improve? What would you need to do more, or what didn't work for you? How can I improve this talk, okay? So you can fill in this small form and give me your feedback. Thanks a lot.